welcome to today's webinar. And this webinar really takes a look at the comparisons in terms of time and effort with AutoCAD, AutoCAD Lite, some of the other products that may be out there on the market in reference to AutoCAD, SketchUp, AutoCAD Lite, and those things. And then in comparison to Civil3D, which we all know, Civil3D has a wide variety of tools that allows you to be functional in multiple disciplines. So some of the things that I'm going to look at, and of course, because of the 100% of everyone knowing or using Civil3D, some of you are familiar with some of the things that Civil3D will do. So there is a number of things that I'm going to kind of take a look at. I'm going to show some key findings, look at some general civil design workflows, and then what some productivity gains may be in terms of using those workflows, and then some of the capabilities in terms of what you get in the current version of Civil3D as it stands today. And then in conclusion, I'll show some of those things. But if there's some things that you have on your mind or things that you've run into or some situations that by all means type those in and I'll try to address those also. But clearly there are some pain points if you're using AutoCAD, and not to be confused, a lot of new customers know how to use AutoCAD, and some customers always reflect and say, why Civil3D when I can do these things in AutoCAD? And of course, those are some of the comparisons that we will look at, because technically you can do some things faster with AutoCAD than you can with Civil3D. But of a long-term cycle of a civil project, AutoCAD minimizes the value in your return in terms of functionality, efficiency, and productivity in terms of using software. So as we move on here, again, ultimately what we found in terms of key findings, overall productivity gains, in terms of 43 hours when using Civil3D, other than a AutoCAD to complete some of these tasks. And again, I'm going to show some of those things. And a lot of the things that we want to be able to look at outside of the small picture is some of the tools that would make us more functional and more efficient and more productive in terms of using Civil3D. So again, accuracy improvements and then risk reduction. We'll take a look at all those. So in reference to civil design workflows, every project is different in terms of infrastructure. But I'm just going to kind of represent some of the things that a user would typically do in terms of working on some of these things in terms of maybe survey, parcel design, alignments and profiles, maybe some piping, some grading, and then roll design. And then ultimately, maybe some planned production if we get to it. But again, if we look at some of the typical tasks that are usually done with AutoCAD, and then you look at how Civil3D addresses those things, you will see the advantages in terms of working with Civil3D. So for instance, we're talking about a topo. Typically, if you're working with a civil infrastructure project and the project requires a topo, we'll look at some of the steps in reference to data from a topo. So in AutoCAD, typically you're getting data from a surveyor and then having to bring in points, edit those points, put those points in a table, and then work with AutoCAD. In Civil3D, data comes in straight from a field book, straight into Civil3D. From that data, you can create survey database, have all the field data complete, and put in reports automatically from Civil3D. So there's some differences. So if we look at what surface creation in AutoCAD, if we bring in a point file, now we need to draw in triangulation points with AutoCAD to make a 10. In Civil3D, we import a point, create a surface, and the 10 is automatically generated. So in terms of savings, we're looking at 99.5% time savings. And again, if you think about interpolation and creating a 10, that was being done over 30 years ago by hand. So if you think about doing that actually in AutoCAD right now, time saving is a big issue. And then we look at things like spot level and grading and labeling with AutoCAD. And it's a common place to label spot labels and over the surface at key locations. And with those spot elevations, you can give an idea in terms of guidance to a contractor in terms of grading. And AutoCAD, pretty straightforward. So there's some things you can do that are quick in AutoCAD. But overall, longer time period, if you're building a Civil 3D model, if you're looking at spot elevations, if you're looking at slopes, that's populating by picking a point or 2 points with Civil 3D. In AutoCAD, it's rise over run. And again, something that's been around for 30 plus years in terms of an application or using a calculator. Those things have been done over the years. But if you look at spot level and grading level with Civil 3D, once you build that model, all the information and all the data is contained within the model. So it's just about the process of picking a point, picking 2 points, or even dragging that point along in reference to spot elevations or labeling. So again, automatic labeling, dynamic labeling, reducing the chance of error, referencing the model built by Civil 3D. And if we look at some of the other things in terms of quick selection in reference to surface conditions, now clearly you can add spot elevations and slope elevations in AutoCAD. But what happens if there's a change? What happens if something needs to be modified? Then now you're looking at time. And over time, we found that with Civil 3D, 97% in terms of time saving over AutoCAD rather than Civil 3D. And we'll look at things like generating a profile. In AutoCAD, we're talking about offsetting lines. We're talking about measuring distances in terms of vertical and horizontal exaggeration. In Civil 3D, we can just tell it. We can pick out a line, and based upon the surface, we can do a quick profile. And we'll look at some of those things because we need to be able to see how some of those things are done with Civil 3D as I'm talking about these things. But ultimately, if we look at working with AutoCAD in terms of those workflows for survey, surface creation, analysis, and working with AutoCAD, we're looking at about 507 minutes in terms of task. If we look at Civil 3D, we're talking 7 minutes. Now, clearly, there's a difference between topo, surface, and we did make reference to GIS. That's another story. But spot elevations and quick selection, you can see in terms of AutoCAD minutes and Civil 3D minutes what time savings you realize working with Civil 3D. And as we move on, we start looking at things like parcel design. Well, this workflow makes reference to parcel creation, whether existing parcels or design, and then reporting. And then from that, what value do we get from that if we're creating it in AutoCAD, and what that looks like in Civil 3D. And clearly, the first time you start is not going to be the last time, because we start out with a concept plan first. And if we make changes, again, with AutoCAD, a lot more time involved in reference to that. So if we start looking at parcels that represent legal descriptions or parcels in terms of subdivided land, a lot of projects have this existing parcel information, adjacent parcels that need to be divided by the project. Typically, we're going to use a legal description. Based upon that legal description, make adjustments, and then create these parcels per for a phase or based upon the project. And what we found, because working in AutoCAD, we need to set up the units. We need to work with dynamic input in terms of drawing angles and distances. In Civil 3D, we basically type in a line based upon bearings and using transparent commands with quadrants, and we're entering data. And we found that 82% of the time when using Civil 3D, you have 82% time savings. And most of the time with AutoCAD, once you draw it the first time, that's it. If you need to make modifications, now you're talking about erasing or recreating data. So it's slightly different than traditionally drawing horizontal angles, distances, bearings. So with parcel design, of course, with AutoCAD, you're measuring frontages and drawing polylines, properties, closed polylines, and then computing that acreage from a calculator. Now to design proposed parcels, we're setting up in Civil 3D specific parameters that we want to give the program, and then we lay out those parcels based upon those design parameters. For instance, parcel area, frontage, offsets, and then a layout tool. And we found that 35% efficiency gains when using Civil 3D, and we're not making reference to making modifications or changes once the parcels have been drawn. But with Civil 3D, the Civil 3D tool allows confirmation for lot size prior to creation, edits of the size after creation, and then recalculation as the parcels are being generated. And we'll take a look at some of those things also. And clearly, some of us have been using Civil 3D, and there's things that we like and we don't like, or things that we wish that we had. By all means, type those things in so we can talk about those in the end also. But ultimately, once we get those parcels drawn, we want to be able to report those in a format that a graphical representation will be able to display in a table. From that, with AutoCAD, clearly, there are some challenges there. With Civil 3D, because we've created the data, we just add the parcels to the table, lay out the table, and we have that information. And we found that 64% in terms of efficiency working with Civil 3D. Again, AutoCAD, everything about AutoCAD is manual creation. And if we need to create fields, that lends itself to user error and retyping data as needed. As we lay out the data in Civil 3D, the information and labeling is already created based upon our layout. As we move on, ultimately what we found is 74% gain in efficiency. And that's with parcel creation. Even if we had to input existing parcel data, parcel design, and then according reporting for tables. And clearly you can see the differences between the two. Then we move on to something similar to a road design or road layout. And to get there, we need to talk about horizontal geometry, vertical geometry. And then whether we get into something as simple as a straight road, a driveway, intersection, a T, or a roundabout. The more complexity that's involved, the longer things take. Now, if you think about what you're doing with that in AutoCAD, there's a lot of challenges. Because horizontal layout, clearly, you're going to do that in Civil 3D. So from point of beginning, distance, bearing, and then tangent, and then alignment, and then circle, tangent, radius, if necessary, depending on what we want to create. We can create that in AutoCAD. That's just drawing lines, arcs, bearings, and distances. With Civil 3D, we can give it parameters, and it automatically, from our point of beginning, lays out those horizontal commands based upon bearings and distances and tangents and its proper locations. The curved arrow is placed from our tangent in and tangent out. Of course, in AutoCAD, we need to create that. It's not dynamically inputted like it is with Civil 3D. And in the findings, we found that 72% and I'm going to say 73%. We're just going to round that up in terms of a game using Civil 3D. And if we come to the next point of actually laying out an alignment. In AutoCAD, we can see that there's multiple steps in reference to our alignment, but ultimately from that alignment, we should be thinking long-term in terms of what we need to get from an alignment, which ultimately is a profile for horizontal and vertical information, and also triangulation, distance, elevation marks, grid marks, vertical distance, and also sections. To do that in AutoCAD requires a lot of information and data. In Civil 3D, we create an alignment, we create a surface profile. From that surface profile, we create a proposed profile, and from that data, we create sections based upon the volumes and sections that we create. So it's pretty straightforward, but ultimately, if you're using AutoCAD, profiles and section views from the elevation surfaces along the alignment layout requires a lot of time. And it's typical for those views in a profile to have a vertical exaggeration in multiple views. With Civil 3D, we can just change what the exaggeration is. Ultimately, we found that 99.9% time savings using Civil 3D. And that 0.01%, I'm just going to raise it up to 100% because the AutoCAD process is inherently inaccurate and imprecise. And it's required based upon the user. And it also depends heavily on information that's provided with large amounts of data. So ultimately, once we get that data into a drawing, we need to be able to label that. In AutoCAD, we're talking adding labels based upon chains and text and data, perpendicular and distance from beginning of a curve to end of a curve, and all types of horizontal geometry. In Civil 3D, the labeling process occurs immediately because the layout controls the labeling. So 100% productivity gains when using Civil 3D alignments, profiles, and alignment geometry in terms to achieve what you want with profile and sections with Civil 3D. Specifically, now we start in reference to a vertical layout. Same thing in performing those tasks in AutoCAD requires a lot of creating circular and parabolic arcs with an exaggeration. And it's just not realistic in terms of time saving with AutoCAD. But in Civil 3D, straight out of the box, create profile, creation, tangents, vertical, free curve data automatically. And we'll take a look at those things also. Moving up to a little bit more complex, now we're talking about intersection design, roundabouts, and cul-de-sacs. If you've been using Civil 3D, you know from the roundabout tool or the intersection tool, that's in seconds. In AutoCAD, we need to offset alignments from the major road to the minor road, offset curve returns, offset a bulb in the cul-de-sac, offset roundabouts, circular roundabouts, creating offsets from, there's a lot of work that's required in reference to using AutoCAD. With Civil 3D, we need two alignments crossing. From that alignment, we can create an intersection. From Autodesk Vehicle Tracking, which is a part of Civil 3D, you have a roundabout tool. All that's required is one step in reference to what alignment, or one path, or an intersection. And if you had multiple roads coming in terms of the arms for your roundabout, Civil 3D addresses that in seconds. And ultimately, we found that 80%, 86% productivity gains working with Civil 3D. And in AutoCAD, it's not that you can't do it, but it's going to take you hours and hours to complete what it takes in seconds with Civil 3D. So ultimately, using AutoCAD, the design process, if a change is made, is not dynamically linked. Of course, with Civil 3D, any change that you make is dynamically updated as you make that change. So it's just some really things, but ultimately a 97.8% came in reference to using Civil 3D. So from horizontal and vertical to horizontal layout to profiles and sections, labeling, vertical layout, and then of course, intersections and roundabouts. From that, okay, and we're moving right along here. We move on to piping and drainage. Now, clearly, if you don't have a calculator, there's no piping and drainage with AutoCAD because everything requires calculations. So in terms of a typical workflow, surface analysis, we talked about the shortfalls with AutoCAD. If we don't have a model, then laying out data requires Excel spreadsheet and data created. Well, with Civil 3D and a surface, all we need is a layout and a finished ground surface to calculate piping and drainage. All we need is a surface. And that's just a step. But clearly in terms of profiles and production for plans and profiles and structured tables and piping tables, a lot easier with Civil 3D. But by creating this drainage system in AutoCAD, clearly we need to determine where natural drainage and all these things occur. With Civil 3D, with the surface, we just pick a point and we lay out a water drop and find what our lowest point that we need to drain to. Catchment areas. Just simple things that we would typically use in terms of what we're thinking opposed to what we're asking. So water drop tool, water will run across the surface, catchment areas determine the areas that's going to be going to a specific drainage point. Based upon those points, water concentration that we're going to determine that's going to contribute to our water collection or detention pond. So 62% efficiency gains. That number has changed dramatically to 87%. So while the time differences in AutoCAD doesn't appear significant, that difference is compounded every time you make a small change, whether it's from a catchment or an elevation or a drainage line. And of course, AutoCAD is heavily required upon data that you have to create in tables. So again, network layout, horizontal, vertical, we're going to take a look at those things. And then overall, 74% time savings. And we're still talking about a grid. So as we start compiling these things in AutoCAD, they're taking more and more time. In Civil 3D, we're at the same point in reference to our model being built. So in Civil 3D, the process is based upon the modeling information. And once the modeling information is built, laying out things is pretty straightforward. And then ultimately, in terms of plans and profiles, in AutoCAD, we can lay out what goes back to alignments, horizontal, vertical, profiles, and then a title sheet. In Civil 3D, we create a view frame, create a sheet tool, and it creates our sheets for us automatically. And then we're looking at 83% greater efficiency. And this is only if, for the first time, we've done it in AutoCAD. Because once we make a modification, that number raises significantly. And if we're talking to manhole schedules and things like that, again, AutoCAD tables, opposed to Civil 3D data. And ultimately what we've found with surface analysis, network layouts, crossing pipes, drainage, manhole schedules, we've found time savings using Civil 3D ultimately averaging above 85%. 90% gain, 22 minutes opposed to 250 minutes. And then if we start getting to the grading, and grading is always point to point, rise over run. But with the Civil 3D tools, everything is dynamically updating as we work with our model and based upon our design parameters. In AutoCAD, we're talking rise, overrun, and interpolation. Whether that may be a parking lot, clearly in AutoCAD, you can find an elevation, tie to that elevation and say, I want to go a certain distance, rise, overrun, divided by, times the distance, divided by 100. You can get what that elevation is. In Civil 3D, you just move your cursor and it tells you what it is. Ultimately, the findings have shown that there's 91% time savings for parking lot or grading just in Civil 3D in itself. And there's a lot more details in terms of verbiage that we want to look at. But once we get into road design and things like that, overall, a lot of the data that's contained in terms of findings and productivity are shown in a document and a spreadsheet that clearly defines some of these things also for lots and lot layouts. In AutoCAD, subdivision grading or parcels, we talk about laying out parcels. In Civil 3D, we just draw a line and say, okay, based upon these parameters, show me what this parcel looks like based upon these parameters. And we look at 78% gains in reference to subdivision and grading. AutoCAD process also always requires estimation. The beauty of working with Civil 3D is once we build that model, estimation is based upon the changes that we look at dynamically. Ultimately, for parking lots, road design, subdivision, and if we looked at ponds, we're talking an 85% gain in Civil 3D. So in conclusion, based upon time savings, with Civil 3D is more efficient than any product out there on the market. In comparison to AutoCAD and AutoCAD Lite, if it's a civil infrastructure project, the far majority of tasks that you're going to work with in terms of working with AutoCAD are going to be significantly higher working with AutoCAD. So we're talking hours savings. And some of these tasks equal in time, but again, over the life cycle of a project, time greatly increases using AutoCAD. And for designers and users, there's a peace of mind that design features have when they've created and updated, because everything changes, all your labeling changes, all your accuracy and precision throughout the project and life cycle of that project. And the final time differences you kind of can see. And some things I didn't take a look at, but these other things are documented in reference to the differences detailing between AutoCAD, AutoCAD Lite, and Civil 3D. Now, before we get to that, at some of the differences, we just want to take a look here at some of the differences. So we talked about the ideal of just bringing in points. And of course, we're talking about a number of points. So with Civil 3D, it's pretty straightforward. I came up to points, import points. AutoCAD, we know we can bring in points. But with Civil 3D, we can just bring in a point file. And with that point file, we'll give it a file format, and again, we're talking minutes and seconds. So with a point file, similarly to what you can do with AutoCAD, you can bring in points. And this will take a second here in terms of bringing in points. As my screen catches up.
Hey, Ken, we've got a comment in the chat box. It says, can you hide the share screen at the bottom? It's covering text.
Of course. So hopefully we can see that now. And one of the other things that you all can consider is that everything that I've talked about is documented in a PDF. So we will be able to look at some of those things. But we've brought in points, and these points, of course, with Civil3D, pretty straightforward. We can come in and display our points with elevations and descriptions. Pretty straightforward. In AutoCAD, yes, you can bring in points, so we can do those things. But from these points with AutoCAD, I want to be able to draw, and we're going to do this quick. But from node to node to node, and I can object snap to a node, to a node, to a node, and back to that node. So in AutoCAD, we need to be able to create these triangles and interpolate these triangles based upon points to create our contours. Now that's just an example of one triangle. I'm going to erase that. And again, it's about time savings. In Civil3D, we want to just be able to create a surface. From our surface, all that surface existing ground, from that existing ground surface. In terms of time saving, with AutoCAD, I've created one triangle, no contour. In Civil3D, I just add a point group. I select OK. I've got my contours. Not only do I have my contours, but if I pick on my surface, and from my surface, because this is a model that's been built, my triangles are created automatically. If I pick on just something, a point in regular AutoCAD, which is pretty straightforward, just a point in regular AutoCAD, we're going to cut this point off. And we could have just froze that, but it's a process. So all these triangles, now you're going to do this with AutoCAD. If I hold my cursor anywhere on this site of this model, it's giving me information about my model. So surface analysis, if I pick on my surface, as an example, because we're talking about the differences in AutoCAD. If I pick on my surface and go to surface properties, well, in AutoCAD, if I'm working with a site, I want to generate surface, I want to generate elevations, I want to generate data in terms of analysis. With Civil3D, it's all contained here. If I want to do elevations, there's my elevations. If I want to do low points, I can determine where my low points are. I can do all those things. If I want to do slope banding across the site, I can delineate where my slope's at across the site. Steep slope analysis, I can do all those things. Or I can come back and say, okay, I just want to show contours. Again, the data based upon Civil3D, it's about the modeling information. So if I came in here and said, okay, I want to show contours, I can show contours. If I came in here and picked on my surface, and again, I'm showing you some of the productivity gains in terms of using Civil3D. If I came in and said, I want to add spot elevations, this information is derived from the model. So if I need to move, this information is derived from my model. If I came in here to my surface and said this surface had a bust of 200 feet, in AutoCAD, you have to redo everything. In Civil3D, there's my change. Just some quick things you want to be able to do in terms of this ideal of working with surfaces analysis and Civil 3D in terms of gains. So again, when I say a 98% gain between survey, surface creation, surface analysis, and also spot elevations, I mean 98% gain in efficiency and productivity. Because these things that you're going to do on AutoCAD requires hours. So we also talked about this ideal of working with parcels. And working with parcels and alignments and things like that. Well, let's look at alignments. In AutoCAD, if we draw a tangent in, a tangent out, we can come in and say, we want to run a fillet, and we can say that fillet radius, I'm going to say 200 feet. I'll pick my tangent in, I'll pick my tangent out, and there's my 200 feet. And then I have to go in and add stations based upon perpendicular to my line work. In AutoCAD, it's a little bit different. We'll say create AutoCAD, a little bit different. In Civil 3D, we'll say create alignment based upon curve and spiral settings with a cloth-weight curve. I select OK. And then I say draw tangents with curves. And I'll say here, 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 and here. And all my horizontal geometry has been created. Well, maybe I need this for a 50 scale. Maybe I need this for a 100 scale. Well, if I came down here and said, okay, I need this for a 100 scale, all my text dynamically update. And you're not going to get that in AutoCAD. And if you do, you have to recreate that data. And those are some of the things, again, productivity gains that you want to take a look at. So from this, again, even if I did selected alignment, from that alignment, I can add label stations, station and offset, snaps to my alignment horizontally, radial, pretty straightforward. Data is created. But interestingly enough, the data is generated from the model information. And as I move my data or my point, it's dynamically updating. So from horizontal, and it's something as simple as this. If I drew a polyline, in AutoCAD, how do I create a profile that shows me what the elevations are on the surface? Well, start drawing a line. And then from that line, I start offsetting lines, 10-foot increments. Or I can run to get my grid in reference to my vertical and horizontal exaggeration. Yes, I can do that. Or in Civil 3D, I can pick on my polyline and say, oh, I just want to do a quick profile. And based upon this quick profile, I want to put it in a grid. Again, we're talking minutes and hours compared to seconds. And that's why these design workflows show productivity gains from AutoCAD that ultimately in Civil 3D takes seconds. And if I need to exaggerate what this scale is for my profile view, I'll just pick on it, edit profile view, and I'll say I'll change the exaggeration scale. There's my change. In AutoCAD, now we have to redo all that over. So again, productivity gains. And that's what we look for, because Civil 3D has a variety of different tools in its toolbox, but we just want to utilize the tools that address the things that we need to work on. So if we look at something as simple as working with parcels, something as simple as working with parcels. And minimize that again. And then I'll go back, and from that, from Civil 3D, we'll look at something as simple as this drawing. And from this, we just have this alignment. So we show what the alignment looks like. From this, we have this parcel. With Civil 3D, I drew a rectangle. AutoCAD. And then from that left times width, and then this area, we can get that. So if I picked on this from AutoCAD, we go into properties, we can get the area and length. Civil 3D, I'll just go to parcels, create a parcel from an object. And I'd say from this, one name square foot area length. There it is. If I make a change, then that change is automatically, dynamically updated. Bearings and distances and my area. AutoCAD, not so much. And ultimately, if I get into an area here where I say productivity gains, well, I'm going to lay this out with AutoCAD. I'm going to offset, make sure these lines represent the square foot and area. With Civil 3D, I can come in and say, create parcel tool. I can come in and say, I want to give it parameters based upon minimum area, minimum frontage, the frontage, offset, width, depth, which is required in terms of my area for my parcel. And just come in and say, okay, well, I'm going to use this slide angle. I'll come in and say, okay, well, I want to make sure my acreage and square footage is based upon 1/4 of an acre. And I'll pick my parcel. And it says, select my starter's front. Well, I'll pick right here, and I'll drag it to here. And then it says, specify my angle. I'm going to go 90 feet. There's my parcels. If I don't like those, and I want to make adjustments, I say no. And on AutoCAD, there is no, you have to redo it. We go back 90, and then I'll accept those. And then I'll come back. I'll say, okay, well, I started on the frontage here. I can come back, pick that point, and start here. I can add in parcels dynamically. Make changes on the fly. Bearing and distance, acreage, everything dynamically updates as I move my parcels. Again, productivity gains, parcel creation, input of parcels, parcel design, reporting. Well, what about reporting? Well, if we come here to the toolbox, and I come to my reports manager, I say, well, show me the areas of my parcel. I'll select OK. I'll select save. I'll select yes. There's all the areas of my parcels. Do that with a calculator in AutoCAD. Again, it's about productivity gains using tools that ultimately give you an advantage in terms of design workflows.